It works. Hi. I feel a bit like an outlier because I'm the only presentation about security in the whole conference. So maybe security is no longer a topic in video delivery. Don't worry, I will not talk about security. I will talk about CDN and a lot of different things, and edge processing. So it's a joint work with Gwenaël Deur, who is from Content Armor, which is a company doing watermarking, which has been acquired by Cinemedia 2 years ago, and John Prakash, who works on the CDN performance evaluation. So first, remember why we need watermarking in our delivery pipeline. So as you can see, on the left side of this figure, we can see the legitimate video delivery platform. So this is where we use the CDN to deliver content to the end users. And among these end users, there is a bad guy. And this bad guy, or maybe his account or her account, has been hacked. So this guy, at least, become a leak. And this is the source of redelivering the stolen content to the platforms and to the pirate platforms. So usually what we do is that we try to deploy anti-piracy system into the legitimate system. We monitor the pirate systems to get the video source, and then if we can do the revocation of these users in the legitimate platform. So this is how it is supposed to work, and watermarking is for this. In this presentation, I will only talk about how to deliver watermarking into the legitimate systems, and this is why we use forensic watermarking, which is we include or insert marks into the videos, and these marks contain a unique identifier. And what is a good watermarking solution? Is a solution which does not impact the quality of view for the end users, for the human, but it is visible for the system, and it should be robust because people can take pictures, distort the video, and it should still be possible to see it, and it should not add too many data into the video content. So the state of the art is this A/B watermarking. So the A/B watermarking, on the left we see the, I cannot see. Okay. We need to produce two versions of the video, versions with a mark A and a version with the mark B, and we need to deliver both video until the edge servers. And when the end users make the request for the segment, the request contain a token URL or a token, and in this token we have a client ID. And then, based on the client ID, we can decide if the next segment should be A segments or a B segments. So it is server-side watermarking. It guarantees that eventually we will be able to have a series of watermarks of segments which is unique for these end users. So if we wait enough time, we will be able to identify these end users for sure. So the A/B watermarking is today's solution for watermarking integration into the distributed delivery. It has some weaknesses. So first, we have only A and B. We could technically have a C version of it or a D version of it, but it becomes too big. And so this makes that we can only have power of 2 for every segment. So it means that the unique series of watermark is only available after a long time. Okay. The second weakness is that it is a double footprint, so you need to double the storage, double the processing in the video head-end, so it adds some burden on the CDN. And the third one is that the synchronization pipeline is a bit complicated. So I can do some advertisement for DashIF, which is at this time kind of offering a solution which is expected to be a standard for the management of A/B system at the edge. So, but despite this, it still requires fine-grained. You need to have the segment ID file name in order to be able to decide which A and B files should be done, and that could be complicated despite the efforts which are done in DashIF. So the solution that we designed with Content Armor people, I mean, Content Armor people brought this to the reality is a modified version of the watermark where we do the profiling just after the encoding. And what we do in the profiling is that we identify the marks, but we don't integrate the mark into the video. We just indicate in which locations in the segment we'll need to include the mark. Okay? So we find the best marks, and we add this information about where should be the marks as a metadata into the SEI, the supplementary enhancement information. Okay? So the video is untouched, and we just have this SEI which indicate which bytes should be changed. Then we go to the encoders, and we go to the origin servers, we go to the edge servers, and when the edge servers receive the token from the end users for the integration of the watermark, this is where it applied the changes. So this is the edge server is expected to modify the payload of the video to include the mark, and this is done at the edge of the systems. So the main advantage is that it's a simplified pipeline because you don't have any dependency to segment file name. You use the information in the token to modify some of the marks. Obviously, not all people will have the same marks and the same modifications. The main advantage is that it's a single footprint. So you only need to have one version of the video in the edge. And the third advantage is that in theory, you can have multiple variants of the segment, meaning that instead of being stuck to A or B, you can have potentially 4 or 5 different segment versions, which means a shorter sequence in order to identify the end users. So this is the solution. Another view of this solution is that the client sends the URL plus the token. Then at the edge, what we should do is that we should extract the video segments with the metadata. Okay? We derive the client ID from the token. We read the embedding instructions into the SEI, and then we make the modifications. So some additional information. First, the SEI is a metadata which does not encode video content, so we don't need to decode the video to apply the change. The SEI information just say, here is where you need to do some modification to integrate the marks, because it takes into account the encoding. Okay? And the SEI is not encrypted, and so we don't need to decrypt the video segments for the integration of the marks. So it means that the modification, the embedding of the marks apply on the compressed and on the encrypted domain. So it's AES-CTR and AES-CBC. Another element is that one single video segment can generate multiple versions of the segment variants, because multiple variants of the segments, because we will modify some of the marks in the system. So it's a bit of magic to modify an encrypted compressed video, but it works. It works. So we wanted to, and we promised that we would reveal some numbers because this is information that is interesting. So the first number that we want to share is the profiling part. Is it actually possible to find into live video streams some marks? So it appears that it does. So on the y-axis, you have the number of marks per segment. And on the x-axis, we have the CDF. Because some segments do not have the same number of marks. I mean, we did not identify enough marks into the, potential marks into the system. So it's a bit of a novelty compared to A/B watermarking, because with A/B watermarking, you have the A, you have the B. And here, we will have different numbers of marks. So it means a different number of metadata into the SEI, and potentially a different number of operations to execute at the edge. So this is something which can become complicated, but this is kind of a novelty. So when people ask me what would be the impact in terms of size of the metadata, it stays low. It's like less than 1% of the video, but sometimes it is very few, and sometimes it's a bit more. It can be up to multiple thousand for large, high-resolution video, and it's less for the lower resolution. But what we show here is very low resolution, and we still manage to have enough marks to make a distinction between multiple clients. Okay, the second one is a bit more problematic. It is the embedding. So this is the main question, right? This is you will have half the number of video segments into your storage, so you will gain in terms of storage, and you will gain by a big factor, but it has a price in terms of embedding. So on the x-axis on the left, this is the blue bars. It is the CPU. What we observe is that the CPU is negligible, because basically what we do is that we extract the information about the location of the modification to include into the video, and we just switch the byte in this place. So this is something which does not require a lot of CPU operations. Okay. However, we have a slight problem, which is common to the edge processing community at large. Is that what we observe is that for, relatively high resolution like this, on the y-axis on the right, we have the TTMS, which is the time to process the full request and to send the last byte of the systems, and it kind of increased dramatically. And dramatically in French means that it's catastrophic. So it means that if you have more than 4,000, 5,000 end users, you will become with, you will have a long time in processing. And this is for 2-second segments. So you will eventually be stuck by the time. So we are trying to address this solution, but I want this problem, which can have an impact in terms of scalability. It's kind of related with edge processing. So on the left side, this is a traditional edge cache request processing. It first goes to the servers. The servers goes very fast to the cache. The cache extracts the data very fast as well, and it immediately sends a batch of data that it extracted from the NVMe drive or from the RAM to the NIC card, and the NIC cards can send it with packets into to the clients. When we go for the edge processing system, and it's common to every edge processing system, is that you will need to extract the batch of data from the storage. So here you are limited by the NVMe communication bus and the I/O of the hard drive, right? And then instead of putting that directly to the NIC, you need to copy this to the RAM, so that then you can do the operation that you need to do on the systems. And this communication between the CPU and the RAM can be bounded by the I/O of your memory RAM, right? So in that case, the bottleneck of your whole servers may become something which is neither the hard drive nor the NIC card, but it can become the access to the RAM of the systems, which with PCI Express 4 and 5, you have something which is close to the performance of the hard drive servers. So here, what you need to do to address this kind of elements is to have a better thread management, have a very fine-grained policy for the batching, for the bus communication to the memory, and you need to be a little bit faster for this. So takeaway for this is a new approach for server-side watermarking. It kind of fixes the main weaknesses of AB watermarking. In terms of implementation, it has a marginal impact in terms of CPU, but it requires tricky and fine-grained settings in terms of your server management systems. And that's it. Thank you.
Okay, thank you. Let's make time for a question. Any questions out there?
Thanks for the talk, very interesting. Maybe I missed it, but how do you actually identify the pirate when they're playing back the pirated content, like the watermark content? How can you actually tell that?
So yeah, so this is the part which is where you monitor the pirate systems. So you need to have an account on the bad peer-to-peer systems, but it's for good. And then so you see the video that has been leaked. And so this video contains the marks. So if you watch the video long enough, I mean for a long time, you will observe the mark and you will see, okay, this is Ali. He's a leak into multiple pirate websites. And you will observe the mark, recognize the sequence of A and B, or the sequence of different segments in our new version, and you will be able to, and you have the user ID which comes from the token which is associated to the segment stuff. So it's a full system to have.
Okay. Okay. One more question, and then we got to go because we're running late.
Yeah, so thank you, Gwen. Sorry, I missed it, but how do you insert the mark in the compressed segment? Because you need to change it. How do you insert a visual mark in a compressed segment? Because it's going to affect the compression. So that I missed in your presentation.
Yeah, so it's part of the magic of the watermark, forensic watermarking system, that you identify in the byte stream some locations where you can modify some colors, typically in your video frame, and this will not be visible to your eyes, but it will be visible by a machine which checks these marks. So this is supposed to work in the. I mean, it's not supposed. It actually works on the compressed domain.
Also after transcoding as well.
After transcoding as well.
Congrats.
Okay. One more question since you look so anxious on it.
Sorry, similar question to what these guys were asking. You were saying that the modification is in the metadata, so you're somehow transferring the metadata modification to a perceptual video change.
No, we observe that on the compressed byte stream, if we change the byte number 44, it will have an impact on the frame, but this impact will be unnoticeable for you, and it will be visible by the machine. So what we do is that in the SEI, we say 44. And so in the edge, we get the information from the token, and the token tells us, should I change the first mark? And if it is yes, then I change the byte number 44. And if it says that I should not change it, I don't change it. And so since we have like 3,000 marks into the video for the segments with the most marks, then we can actually create not a unique, but eventually a unique video.
You can embed the perceptual watermark without decrypting the video.
Without decrypting video.
All right, thank you. Round of applause, please. And if I can get the next speaker up.